Oh. Hi, can you hear me okay? Is that mic working? More or less? Okay. So thanks for having me here. I'm really excited to be here to share some work we've been doing. So I'm interested in how we learn from our experience and use that experience to make decisions. So one decision that came up before the session started was what you had for lunch and how good it was. So that's one good example, and I'm going to use that one in my own way here. So imagine you're at the market and you're looking around for some, say, fruit. You come across this novel apple type that you never had before, this really dark one. And you decide to give it a shot. You go home, you try it, and maybe it's like one of the best apples you've ever had. So flash forward to the next week. You happen to be at the market again. And you walk by, that apple catches your attention. You think, well, OK, it'd be good to have some apples. Maybe that one would be good again, based on that single episode you had. But also, there's other apples. You have this other favorite that you've had many, many experiences with over your whole life. So it has a reliable, positive value. So these are two examples of the kinds of information that we can use to make our choices that I'll be focusing on today. So in the one case, a well-learned association between something you've had for many years, that's good, and in the other case, just a single episode. So the choices between fruit are not the most consequential in life, but how we can learn and use that information to make our choices has also a strong impact on our own financial well-being and our health. And in some cases, those decisions and how you learn from those decisions can lead to very bad consequences in the case of, say, addiction. All right, so in part one, I'll talk, oh, that's really small somehow. In part one, I'll talk about episodes. In part two, about what I'll loosely refer to as habits. And this is just a shorthand for talking about these sort of well-learned things that you know are good or bad. And some things that you know are good, you might also know are bad in the long term, and you might want to change those habits. So for the first part, from our everyday life and from that example you can identify with, we know that our decisions are often influenced by single experiences or just a few experiences. From cognitive neuroscience, we know that this kind of memory for an episode is critically dependent on the hippocampus and the medial temporal lobe. But surprisingly, we know very little about how these kind of memories might influence what we'll call value-based decisions, decisions based on things that you want to seek out or avoid. So to look at that, we did some initial experiments to ask whether people can use their memories for positive experiences to guide their choices in the lab, and whether, using fMRI, we can find patterns of brain activity for an individual that are active during a positive episode and see if they're reactivated when you're remembering that later on. So, sorry about the small text. There's something from, I think, Mac to Windows. But so the experiment involved learning about some objects, but just one time. So participants played a game where there were either episodes that were associated with a high reward, and they were anticipating getting that reward if they pressed a button really quickly, so it's kind of a rousing, exciting game, or the more boring half of the events which got people nothing. And so they saw many different objects in the experiment, but they were all only seen one time with either that positive event or a neutral event. And then we gave a test to see what they remembered from that and if that influenced their choices. So one test that we gave was whether people would want to play again a given object. So they saw all the objects again for the second time, and they were allocating them into a yes or no, like I want to re-engage with that game, or with that object. And as we expected, we found a strong effect where people chose to play again those objects that were seen once with a positive experience. Another way we looked at this was to see whether people's unrelated decisions about money might be influenced by remembering a positive or neutral episode. And we had them make a simple bet to take a risky option where they had a chance to win, or a safer option where they just got a very small amount. And we saw that priming them or showing that picture right before the bet led to significantly higher rates of gambling or taking that risky option, maybe because they expected a reward when they were primed with that rewarding episode object compared to when they weren't. So from these measures and others that I'm not showing you, we can find in the lab that single experiences influence people's choices. Then we looked in the brain at whether we could see within an individual if there were patterns of brain activity that could discriminate between anticipating and getting something rewarding for an episode and compared to the low reward or no reward condition. And we trained a classification system or algorithm to discriminate these two patterns of brain activity in each person. So we could reliably discriminate these patterns, and that wasn't very surprising. But given that trained algorithm, we then looked to see if, when they saw those objects again just for the second time, and they were remembering or reactivating that original experience, whether we could classify that pattern of brain activity they showed as being associated with a high reward or no reward. So shown here on the left, you can see that we found a reliable, not huge, but a very reliable effect where that brain activity for the pictures that they saw again could be reliably discriminate between the rewarding episodes and the neutral episodes. And then to understand whether this might interact or support people's decision making, we looked to see if how good that reactivation method or measure was in the fMRI data was related to people's performance. And indeed it was, so the better we could detect that reactivation of a rewarding event, the better participants were at saying that something had been good for them in the past. All right, so on the episode front, we know from our own experience that episodes can be really useful. And from these experiments, we know that in the brain, we can reactivate those good experiences, and that might influence your choices. So episodes can be really useful, particularly when you have a limited amount of experience to learn from, like if something really good happens and you want to change your behavior really quickly, or if something really bad happens, you want to avoid it. So those are cases where you don't have the luxury of going through many, many repetitions and learning over time. But just keep in mind that those single experiences that you have, of course, aren't necessarily representative of what you get if you went through and, say, sampled a restaurant many, many times over, say, weeks. And we can take a shortcut online using reviews of, say, hotels or restaurants, and we can see on average what people do rate. So it's that averaging of experience, but with an individual that I'll talk about next. So we'll look at how we can learn from repeated experiences over time and how that influences our choices. So going back to the apple example, so you had that really great dark red apple. I think it was called an Arkansas Black. And it was really tasty, so at the market you bought it again. And maybe over the next few weeks or months or years, you kept buying that apple and enjoying it and enjoying it. And so over time, this apple came to acquire a really positive and reliable value. So if you saw it, you might get a little even excited, especially if you're hungry or if you hadn't seen any apples in a while. And then you might choose it or approach it and so on. So it's that kind of reliable, positive association that I'll use and call a shorthand for habits. So that's important for making many of our decisions automatic. And this is, of course, ignoring the whole act of motor habits where you think about riding a bike and stuff. Of course, those are essential for navigating the world. But here I'm talking about the kind of habits that help us choose to seek out the good options, when you're just choosing which subway route, tube route to get here, and so on. And we know from our own experience that learning these values of these things takes over a long period of time. When you move to a new city, you have to pick up new behaviors and new preferences for getting around, for example, or new restaurants. And after a while, you can build up a reliable knowledge of what's good. You can also build up a reliable knowledge of what's good, but that's something that might be bad for you. So becoming, say, addicted to cigarettes doesn't happen in just a single 20-minute session in the lab. It's something that builds up over weeks and, in some cases, years of experience with the cigarettes and the effect on the brain. But surprisingly, in the lab, we've really predominantly used just a single session kind of learning from reward feedback to look at how people learn. So we wanted to move beyond that to study how people learn over long time periods from reward feedback. So we had a simple game in healthy people where they learned that some pictures were lucky, and if they pressed one button, they'd win a reward. If they pressed the other, they get nothing. Other pictures were unlucky. If they pressed one button, they got a loss, and if they pressed the other button, they could most of the time avoid that. And critically, this kind of learning happened over 2 weeks of training. So they got many, many repetitions of a picture, pressing a button, getting reward feedback, or a different picture, pressing, getting loss or neutral feedback. So they learned the value of those pictures. This is what we'll call the spaced condition. This is where they learn about those lucky and unlucky pictures across 2 weeks. And this is in contrast to the other condition, the masked condition, which is conducted in the way that most human experiments are conducted, where learning is just in one session. So you learn, OK, this tree picture is going to be lucky. And then you get all the repetitions for that in, say, less than 20 minutes. So there were a number of different pictures in each condition, so we had a lot of things that people had to learn about. And the number of repetitions, so the number of times they could learn about each picture, was matched by the end of the experiment, or the end of training here on the right. And so we could look at whether these values, or these positive and negative associations that are learned over time, are better remembered. So to look at that, we gave people a surprise test 3 weeks later, where they, oops, sorry, that's supposed to be overlaying. They were rating those pictures as on the scale going from 0, where that picture was definitely bad and going to lose money for you, to definitely good and going to win money. And the data here is plotted for right after learning. And you can't see a difference in the points for the spaced in blue and the masked in gray, because their performance was matched, which is what we expected. But when you look 3 weeks later at this follow-up measure, you can see that the values that they learned for the spaced trained stimuli over 2 weeks are maintained largely intact, while the values for those masked trained stimuli are collapsing toward chance, or neutral. And it's even more starkly illustrated by plotting this percent of each person's maintained reward rating versus their loss rating for those pictures. So we've shown that we can build up these associations that do last longer than what you get from a single session in the lab, suggesting that we can have a better handle on longer-term learning with this paradigm. Related to that fading nature of those mass associations, we find a strong relationship, and this would be surprising until recently, between learning in a single session and variability in working memory that we just heard about, suggesting it's much more of a kind of cognitive task when people are doing it just in a brief session. In the brain, we find that a region of the striatum was able to discriminate between these stimuli, the ones that were learned over long time periods versus the masked condition. And the striatum is known to be critical for learning from reward feedback in conjunction with ascending inputs from dopamine neurons. As a second note, surprisingly, we also found that the hippocampus was involved here, which showed a very, very strong discrimination between the rewarding stimuli and the loss stimuli, but only when they were learned over a few weeks. So that was somewhat surprising for us. All right, so now that we can look at these longer-lasting associations, there are a lot of things we want to do that we haven't done yet, where you might want to look at how you can unlearn something and replace it with something better. Oop, that's all there. Sorry about that. So we want to look at how these well-learned associations can be unlearned. In particular, why some things continue to attract your attention. Like, for example, you're in a checkout aisle and you look at a candy bar that you haven't had since you were a kid. Why does that happen? How can you unlearn that? And in particular, focus on connections between individual variability in learning and compulsive tendencies and addiction. So that wraps up the habit component. I don't have any key insights on how to change your habits. I'm sorry about that. But just keep on working, basically. If you do want to replace some habit or unlearn something, it's good to practice an alternative many, 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 many times so you build a new habit that you can fall back on. For example, when you're more stressed out and you can't control what you're doing. Like if you have a long day in the supermarket and you grab for the crisps, if you learn, to relax and pick up a different habit to pick up an apple, that might be good. So in summary, we use these two important types of information and largely supported by two different information or learning systems in the brain to make our choices. The episodes can be really helpful when you only have a limited amount of experience, And they also provide rich information that you can use to build a model of the environment, which is a great area of research that I didn't have time to touch upon today. In contrast, learning new habits takes a very long time. In future work, though, we'd like to explore how there might be some shortcuts for these kind of unlearning of bad things and learning of new positive things. So thank you for your attention. I want to thank the ICN master students for the organizing today. It's been fantastic. And my support at UCL with Ray Dolan, and previously at Stanford with Russ Poldrak and funding. And thank you again.